Hey guys, Nexi here, back with another video. Today we're gonna do the review of Anycubic Kossel Linear Plus, a Delta style 3D printer. This video review contains unboxing, assembly, overview, test prints using PLA, PETG and ABS filaments with a time-lapse and close-up shot. We're gonna test the speed of the printer, noise level, I'm gonna show you the few useful upgrades, and we're gonna test heat bed warming up time. So, let's begin. Okay, first thing, let's do the unboxing. Immediately when you open the package, you realize that this is a quality kit. Every aluminum extrusion is covered with a plastic foil, and when you peel it off, you ended up with a clean and shiny extrusion with no leftover dust or metal scraps from the factory. This is everything that comes with the package. Most of the parts are already pre-assembled, for example the carriage and deflector carbon fiber arms. All the wires are now pre-installed. Top and bottom frame with the stepper drivers and the motherboard are also pre-assembled. There is 1 kg of the black PLA, display holder, gloves with a USB cable, linear rails, extrusions, tools, screws, belts, USB card reader, SD card, AC cord, power supply, user manual, and etc. Now when it comes to the assembly, the most important part is installing of the rails on these aluminum extrusions. Here you need to pay attention to screw down these screws with a feel and do not over tighten them more on one side than to another. Try to apply the same force to all screws, and then when you're done with all of them, apply the final force. Speed here is also important because this rails is holding with the screws on the square holder. More speed means the more chance for them to open inside and hold down to the extrusion like they should be. So take your time and do this right. And when you test the rails, they should all slide using the same force, nice and smooth. Everything next in the build is pretty much straightforward. I install all 3 extrusions to the bottom frame, and then I install the top part frame with help of little force. And then I tighten all the frame screws. The cool part here is that the stop limit switch cable is going down to the center hole through the extrusion down to the bottom of the frame. The instructions are great and very well made, easy to follow with the simple steps, so you don't need more than 45 minutes to finish this whole kit. And there is insulation material under the heated bed, which is nice to see. And this is how the 3D printer Delta look when it's fully assembled. Next, I plug in AC cord, I remove the plastic foil from the LCD, and I turn on the printer. Since the black PLA is too dark to show on the camera for the first test print, I installed some white PLA. And now some introduction. This is a Delta style 3D printer called Kossel Linear Plus. And it's very similar to the last Kossel model, but it comes with some upgrades like the more beefier carbon fiber effector arms. They look more sturdy than before. It has auto level probe. It comes with the linear rails instead of the pulley wheels, which should be more precise, sturdy with a longer lifespan. The spool holder is now attached to the frame instead of that acrylic one that you need to assemble yourself. It has the bigger build volume, 230 mm in diameter on the base with a heated bed, instead of 100 mm with a no heated bed in a previous pulley version. It has a much bigger 24 amp power supply with an auto load fan, with an AC switch and a fuse in this metal cover. And like I said, this whole kit is around 50% pre-assembled, so it's much more easier to assemble and less complicated than before. For auto level, this Delta used this metal probe with a micro switch who attached to the carriage with a magnet like this, and then you just plug this connector and you have the auto level when you need it, without adding the extra weight on a carriage. For leveling the printer, there is 2 steps. First, you navigate in the software to the auto bed leveling and then click to the measure Z position. And the printer will measure 38 different places on the heated bed and store them in a memory, and then the printer will reboot. Then you need to navigate in the software to auto bed leveling and then click to prepare leveling and then begin leveling. And the printer will again measure 38 different places on the heated bed and store them in a memory and level the printer. You can also fine-tuning the Z offset when you do the first print by pausing the printer and then click on the Z- or the Z+ depending of your results, and then continue to print. It's very easy and all of these steps are in a user manual. Now for my first test print, I decided to run 290mm cylinder in a vase mode in 0.25mm layer height and see if will be any layer separation or wobble during this test print. The test was successful and there was no wobbling or any print degradation present, so I ran test cube 20x20, but then again I increased the height to 290mm in a Z height. The layer height here was 0.25mm as the previous test print. The walls are just 2 parameters thick, so 0.8mm there. The print surface looks very smooth, there is no any artifacts or any degradation in a print. And I print 2 of those tests, but this one was rotated by 90 degrees. I just want to compare to see is there any difference in a print quality, but nothing major there. They look very similar to the first one, so all of these 3 tests was successful. And now it's time for the 3D Benji. Even the print speed was set on 40mm a second, acceleration by default on this delta is very high, and if Cura estimate 1 hour and 30 minutes of print time, this delta will print it in 1 hour and 7 minutes. So playing with acceleration and jerk settings may help you to get more correct estimated print time. Alright, and now let's see our results. Well, consider that I'm using the cheapest PLA for this test, it's not bad at all. We do have some slightly lines and vibration here on the side, but that's because of that high acceleration in a printer settings. I think it's looked pretty good. And now I print one more 3D Benji using the same settings, but I lower the layer height to 0.1mm. And I lower the acceleration in the Cura, and this is the results. It's pretty much perfect Benji. It looks great, there is no any layer separation or vibration in a print. The print surface is awesome. My next print is the Surprise Egg by creator Age Private Business from Thingiverse. This is a very cool design 3D model, contains for 2 separate objects. This eggshell is designed to hold a small present inside. It has a hinge on the bottom, so you have to have a perfect first layer or it will not open that easy. There is a few versions of this surprise egg, and I choose to print this model with a tiny truck inside. And it looks pretty cool. The keeper is also movable. I printed in 0.1mm layer height, and as well you have to have a perfect layer height, otherwise the wheels will not move. And it fits pretty nice inside this egg. Very cool. My next print is Aria the Dragon by Luby. I print this model in 0.15mm layer height, retraction distance was 5mm and retraction speed was 60. Result is a pretty good overall, except on the small vibration in the middle of the wings and arms. Looks like that the print speed and acceleration was a bit too much, but still it's pretty decent. My next print is again from the Luby and it's a sculpture from Squirrel that require no support. I print this model completely hollow with no infill and the results are pretty much perfect. All the details are present, surface is smooth, nice, but I do find one imperfection here on the shoulder side. It looks like the printer has made some random move away from the shell and back. It might be the corrupted memory card, but we will see. My next print is the Twisty Ways by Time L. Paris. I print out this model in a vase mode in a Cura in a silver PLA, and it turns out perfect. I didn't find any print degradation or layer separation or nothing. It really looks great in all sides and inside as well. Really awesome results. Now I installed some gold PLA and I print 3D Benji again. For some weird reason, Cura version 3.2 is giving much worse results compared to the 2.7 version that I was using to print white 3D Benji. Then I print out one more 3D Benji again using the same settings, just rotated by 90 degrees and with 0.15mm layer height, and the result was not good. Infill is too much visible here and something is not right. Then I installed the latest version of Cura, which is 3.2.1 version, and I print Singing Dragon by Luby, and again same results. Infill is very visible even if I change from 2 till 3 parameters on the wall. And since the temperature and the speed was not problem here, after banging my head for some time I found the issue. In a Cura 3.2 and 3.2.1 version, there is a bug in a nozzle size under delta bolt configuration. Even if I say here 0.4mm nozzle, which is on this Kossel 3D printer, Cura never saved these settings, so that's why I had so poor print quality. I found that the Cura 3.1 version don't have this bug, so I used 3.1 version to slice this next model called Grot Baby by Amba. Results are really awesome. What a difference. I use here 0.15mm layer height and I could go to 0.1, but still, look at these details. They are looking so good now. I'm very impressed how well this model is printed and I'm very glad that I found the problem. So I definitely recommend using 3.1 version of Cura with this 3D printer. And there is a few versions of this baby grot, and I chose this one so I could store some small things like this surprise egg, for example. Really cool. Then I use some Aprinta Grey PLA and Aprint 3D Benji in a Cura 3.1 just to see the results. I use just 2 parameters here on the wall and 0.15mm layer height. Infill is just barely visible just under the special light angle, but this 3D Benji looks much better than before. And this Benji is printed with 0.1mm layer height and with 3 parameters on the wall, and infill is no longer visible and it looks great. Here how they are compared to each other. Very nice. My next print is the owl statue by Kuzva, and my microSD card finally died and left me without finished part. So I had to replace this unknown, no-label microSD card with a new one, and I modified G-code to continue to print on the same place, but I accidentally deleted G-code command for fan cooling and I ended up with a pretty poor results. I had no choice and I print all again, this time with a new microSD card and with the cooling fan set to 100%. Results are pretty much perfect. All the details looks great and there is no heat degradation on the top. I love this Aprinta Grey filament, it looks so good and it gives great results. Here are them both, and the printing with the fan turned to 100% makes a noticeable difference. My next print is a Watchtower by Kijia, again from Thingiverse. I print this model with a 0.15mm layer height and a 20% infill. The results are really awesome. It's a perfect print without any degradation. I tried to get more close here so you guys can see all of these small details. Everything is visible and these tiny stones in a foundation looks really nice. You can see how well is this printed and the level of these details in this print is really awesome. I found no degradation whatsoever, really great results. And since I have the Raspberry Pi 3, let's make a case for it. I print this bottom in a silver PLA and the top in a red PLA. They both came out pretty much perfectly and my Raspberry Pi 3 fits great. Creator of this case is a 0110MPie from Thingiverse. And now since this upgraded model have the heated bed, let's print ABS. I found this funny model Omnion, shell is a 3 parameter thick and I use 50% fan on the top. Results are great. Very smooth surface and a great printed model. My next ABS print is this case for my GoPro. Again, great results and it fits very good on my GoPro camera. And now let's test the PETG. And I print again this Omnium and here it is. I use just 2 parameters on the wall and 0% infill. Results are pretty good. I use 40% of the cooling fan here on the top and it gives pretty good results. Here on the top of the shell where the top layers is, we have some imperfection. Maybe using the 3 layers on the shell can help, so let's test it. I print same Omnion again, but in 200% scale, and 3 layers shell instead of 2. And it looks better, but still, that bulb on the top is present. So printing with a 3 share parameter instead of 2 did not make that much of a difference. I guess adding the infill or increasing the cooling fan could help, but I'm not going to spend more time with this. Overall, this model looks pretty good, surface is smooth, so you can definitely print ABS and PETG with no problem with this delta. And now, back to PLA prints. I got to print this astronaut model called Phil from Mad Hackers. I love this model and it's so cool, and you can print it without any support or infill. It looks great and it's a very well designed 3D model. And now for the end, let's print and install the few useful upgrades for this delta. For example, these top frame caps, they're just click in a place like this. They protect the linear rails and micro switches from the dust, a very cool and simple upgrade. And there is a frame covers from the bottom frame too, very easy to print and to install them. Just slide the belts inside, then rotate it and click them in a place. There is a few versions of these caps, and if you do a lot of ABS prints, then I recommend to print one with the cooling holes instead of this one. It will help stepper motors to cool down better. This next upgrade should hold down the heated bed better in a place, but since this is the heated bed capable of doing high temperature, I print it with the ABS. Since the PLA will probably melt very fast, but you can also use PETG here. But still, ABS is the best choice. Installing of these upgraded heated bed clips are very easy since they're using the same screws, and they fit pretty nice. There is a few versions of these clips, so you can choose others as well. For reduction of the noise and vibration, I use these table pads and they work very well, but I found these feet which are designed to use the tennis ball to suspend vibration and noise, so I decided to try them. Only problem is, my tennis ball are too small for tight fit, so I'm not sure is there a different size of the tennis balls or these feet are just too big. I could use a glue to make them stick better, but that's not the point. I'm not sure that I'm gonna use these feet anyway, so I just used 3M double-side tape to attach them temporarily to the printer just to test them. This 3M tape is holding pretty strong, so I'm sure they will not fall out. And now the speed test. Here you can see this Delta printing my favorite mobile stand with 100mm a second print speed, inner and out walls, and with a 200mm travel speed. I lowered the cooling time to 0 millisecond to make sure that I will have the full speed all the way during this test. This Delta has so high acceleration and it's very cool to watch when it's printing at full speed. I was always fascinated with the Delta 3D printers, knowing how well they work and what unique sound they produce when they're printing. By the way, the noise level is around 50 decibel when they're printing at full speed, so it looks like that the tennis ball upgrade really make noticeable difference, compared to the table pads that I was using before. And after 33 minutes, test print is done. And it looks awesome. This is why I love Delta 3D printers. They are producing much better quality when printing at high speeds because of the Delta design and the low carriage weights, leaving no wobbling and ringing or any other print degradation during the fast prints. This is a very awesome result, and this is printed with 0.2mm layer height, and you can barely see the layers under the zoom. I think this Delta can print this even faster, but the limiting factor here is cooling the filament and not so much mechanical components of this printer. And now the last test is the heated bed warming up time. This Delta hit 50 degrees in 1 minute and 3 seconds, 100 degrees in 4 minutes and 26 seconds, and the maximum temperature of 135 degrees was achieved in 15 minutes and 9 seconds. Which I confirmed with my thermal camera. And I want to point that during this test, this Delta was completely silent and the fan turned on for the first time when the temperature on heated bed was 131 degrees. The fan was on for the less than minute and then switch off again. During the printing with the PLA, fan on the power supply comes on rarely, and when you switch on the printer, no fan is spinning and it's completely silent. Hot end cooling fan start to spin when a temperature hit more than 60 degrees on the nozzle, which is a very nice touch to the details. And now the final words. To my opinion, this is one of the best Delta style 3D printer with affordable price. This is a complete 3D printer and it has everything that you could want. Great print quality, auto level, great components and high quality kit parts. It's a very fast, easy to assemble. It has a fast heated bed with a built tech on. It can print PLA, ABS, PETG and other filaments as well, and the only thing that you should change is probably the microSD card and maybe add a few upgrades like the top frame caps and frame feet to suspend vibration. Other than that, this is a complete 3D printer with a very affordable price and I can definitely recommend it. Alright guys, that was my review of Anycubic Kossel Linear Plus. If you like this video, give it a thumbs up and subscribe, and if some of you guys want to order this 3D printer, please have a look in the links in the video description. Until next time, take care and happy printing. Bye bye.